All right, Math 2150. So here is the second type of example that you will see in section 4.2. And so this type of question asks us to estimate the area under a specific curve, okay? And this specific curve is negative x squared plus 4x plus 4. So it's a quadratic that's open downward. And we're going to estimate that interval from only 1 to 4. And we're going to break that interval into 3 subintervals, okay? So if you've taken a look at this, you know 3 subintervals means we're going to break it into 3 rectangles, okay? So if you've taken a look at the notes, you know that. And the area of rectangles, guys, again, area of rectangles is base times height, okay? Period, base times height. So what's going to happen is I am going to make sure you realize we're only looking at this interval from 1. So right here's 1, 2, 3, 4. So we are focusing on this area right here. Okay, so from here to here is what we're finding. So we've got this curve. You see that? Like there is obviously a curve. So yeah, there's a straight line here and a straight line here. But at the top, this thing is curved. So you cannot use rectangles and triangles to help us find this area, okay? So we are going to take the interval 1 to 4. And so how long is the interval 1 to 4? Well, if you draw a picture like this, it's very easy to see that 1 to 4 is 3 units. However, if you do not see it, my math lab gives you a formula, and they call it delta x. Delta means different, so that makes sense. Delta x equals the base. And you may say, well, how do you find delta x? Well, delta x means take the endpoint, which is 4, and subtract the beginning point, which is 1. And then divide by the number of intervals. And the number of intervals we have here is 3. So we're going to divide by 3. Well, that's very easy to see that that's 3 divided by 3, which equals 1, which means your delta x, which again is your base, the base of every rectangle will only be 1 unit, which makes sense if you draw the picture because we've got rectangle 1. Okay, we're going to find the area of this rectangle. We're going to go find the area of the second rectangle. And we're going to go find the area of the, went too far, the third rectangle. And if we find the area of these 3 rectangles, guys, we will be estimating the area under the curve. Because look, if I find the area of this rectangle and this rectangle and this rectangle, I'm not going to have the exact area under this curve, but I'm going to have a good estimate, okay? And hopefully you realize the more subintervals we have, aka the more rectangles we have, the better estimate we have of the actual area. But for time's sake, we're only doing 3 subintervals for this problem, okay? So we know that we've got 3 rectangles, which means we're going to have to find the base times the height of the first rectangle, plus the base times the height of the second rectangle, plus the base times the height of the third rectangle. If you're using my Math Lab's Help Me Solve, they call the base, like I said, delta x times a particular f of x value, plus another delta x times another f of x value, and then another delta x, because your base is delta x, I explained that several times, times another f of x. So your question should be, why is it f of x? Well, your height is a y value, and a y value is the same thing as a particular value or a particular f of x value. And so your height and a particular f of x are going to be exactly the same, okay? So for each one of these rectangles, we can go in and plug in what we know. We know that the base is always 1, so your delta x is 1 times another number, plus your base is another 1 times another number, which we will go find out, plus your base is another 1 times another number. So we're going to go find these numbers. And again, what are these numbers? These numbers are heights, okay? And so how do we find heights? We plug in f of x. So if we know it was negative x squared plus 4x plus 4, okay, we want f of the first x value, and the first x value right here is 1, which will be negative 1 squared plus 4 times 1 plus 4. And if you want to pull out a calculator, that's fine. But if I just do this arithmetic by hand, I see that negative 1, or 1 squared is 1 times a negative plus 4 plus 4, which gives me a total of, what is that, 7? And guys, because I drew you a picture, you technically do not have to do this step, because if you go look at my graph, look, this is 1, 2, 3, 4, 5, 6, 7. So you can see the height right here. The height of that rectangle is clearly 7, okay? But if you're doing this by hand, you probably don't have a beautiful graph like I did. I just wanted you to see a visual. So in order to find heights, you need to plug in your x values. So the next x value we're looking at is negative 2, or not negative 2, but positive 2. So f of 2 would be negative 2 squared plus 4 times 2 plus 4. So that'll be a negative 4 plus an 8 plus a 4, which gives me 8. And if you go back and look up again, take a look right there. That height corresponds to a value of 8, so I'm doing this correctly. And then f of 3 will be negative 3 squared plus 4 times 3 plus 4. And so if I do that, that's a negative 9 plus a, 12 plus a 4. That's 16. That's another 7. Okay, so if I take a look at this, the height of the first rectangle is 7, so I'm going to plug in a 7. The height of the second rectangle is 8. And the height of the third rectangle is 7. And so because this is such an easy problem, 1 times 7 is just 7. So if I come down here and continue my work, the area, the total area, is the first area plus the second area plus the third area. So the first area was 7, because 1 times 7 is 7. The second area was 8, because 1 times 8 is 8. And the third area is 7, because 1 times 7 is 7. Okay? And if I add that together, I get 7 plus 8 is 15, and 15 plus 7 is 22, which means there's roughly 22 units squared in between 1 and 4. Okay, so hopefully this makes a little bit of sense. But essentially you were finding the area of several rectangles and added the area of those rectangles together. Again, this is called Riemann. I don't know if it's IE or EI.